Hello everyone, my name is Pavel. I'm managing the online company Teamworks with intraoral 3D scanners. This is a device that allows to create 3D client's jaw and later to use it to control the healing process. My very team is busy testing the software that manages the scanners. Small disclaimer, this is not a session to this is just a general description of the work to show you work. Suggest you listen to it. Just for minor license. This is a field that you really come across. The first slide shows the main scanners and the generations of stationary and portable scanners that you can put on the table. There's also small scanners, which is one scanner that is connected to a computer. Special software is used. Manual users are doctors who purchase them for their clinics and use them to treat patients. One of the areas of use of acquired line could be used for restoring your teeth. And they often use it for good.
So the company is developing the aligners to improve biting mechanics. We're interested in this, and attend our stand. Our girls will tell and show you everything. So that I'm done plugging our equipment. Now I'm going to continue. Let's have a closer look at the scanner itself. It consists of the main device, which is called basic unit, and you connect a band to it. The scanning element is called band, which is used specifically for the scanning. Of course, it's not the end of the story. The scanner has quite a robust backend, all sorts of services used for the subsequent development of the model, cabinets and portals for doctors for their maintenance and support. But the scanner itself can build the model initially, autonomously, and as long as my group is testing the scanners themselves mostly, we, in principle, do not depend that much on the environment. Instead, we need a scanner or some other machine like a desktop where you can install the software and do the testing. The only kind of environment we need is one we test cases and integration with the backend. Now I will tell you about the installation of the build installation. There are two ways to install it. In the remote cabinet, you can select the version that you want to install. You can select the scanner, where to install the update, and install it remotely. Of course, it can be used in the real production environment, and you can also use it during testing when we test the actual update mechanism. Second one is the manual stuff. This installation is not that much different from any other software installation. You just launch the installer for the scanner and wait until it's done. my glass has been stolen. Okay, now a bit closer to the testing. Conditionally speaking, we can subdivide the whole scope of testing into two large areas. The first one would be the regular user interface, some kind of fields, buttons, stuff. There is nothing too extraordinary here. Regular testing, like everywhere else, we have some requirements. We make up a trivial key story and our testing like this. Second area that I would like to speak in greater detail about would be the testing of algorithms. Algorithms are building the model. They're doing some initial processing and composition. And it sounds much easier than it is. Even if your test cases are well prepared, to test them would not be as straightforward. You need some experience and skills of a tester. Usually, we do not put new guys for this. A few more words about the second field. I will show some examples for that. For instance, we have algorithm, which is uniting different segments. Segments are the results of one continuous scanning session. We take that, click the button, start scanning, end it, scanning, and at the end we get a segment. This is the kind of example uploaded on the slide. Sometimes doctors cannot scan the whole mandible. If they continue, we have a second, third, fifth, and so on segments. And then you will have to merge them into a single object to work with that. To unite these segments, it makes sense when there are some elements that can be used to match them, some overlaps. And the difficulty of this testing is that you have to verify all these different cases with different fields of overlap to check this functionality. For instance, here, the overlap is 1.5 teeth, basically 1.5 molars. See, the stitching is done like this, and you can paste them like this. Here we have about half a tooth overlap. We have to make sure when not only segments are overlap, but when non-matching segments do not connect because they're different. Half a tooth is not necessary. Stitching won't work. If we still want to stitch it together, you can provide additional scanning in the middle to have some overlaps in the first and second segment. Then all three can be merged into a single model. And this way, by this experience, we can and should collect the full spectrum of cases, which will be covered by the preparation of this test data. We will find all the values of the overlaps, small and big, and all of this should be done manually. And it's quite easy to make a mistake here. The more scans you do, the better. If you do a mistake, then you have to discard it. Here you need to have skills, baggage, knowledge, good experience. When we collected a long list of all our cases, you need to cast a critical look at it and make a conclusion about whether the algorithm works correctly or not, whether these overlap values are good for us, or we need to look at it again and revisit the algorithm, or maybe talk to the production team. That's what the specialist on QA must decide. Another example of the algorithm. The screen shows a segment where a significant part of this molar was underscanned, which can be quite critical for the subsequent treatment because that part of the molar might contain artifacts that potentially can be useful for the doctors. So we have an algorithm which highlights the sections which have been underscanned. You see the highlight in red, so the big gap has been highlighted, but still there is a small part which wasn't found by the algorithm. We'll think logically about this. Our algorithm should have found it, but it didn't. It's obviously a bug in the system. So there's yet another interesting detail here. If you look closer at our algorithm and analyze it, then it's not really a trivial thing like that. And its correction, its perfection might cost an arm and a leg, and eventually it will not make sense to work on it. Another thing to consider that after scanning, there is a post-processing, post-rendering stage where such small imperfections can be additionally drawn. We have looked at it, and in this particular case, we have decided not to improve it. It's not a defect of algorithm; it's an acceptable bias, and our testers sometimes make decisions like that when they compare output with that we receive from our testing. A few words about the testing data. The previous examples have shown that, generally speaking, the testing task boils down to the task of preparation of good quality testing data. If we have scanned everything well, we have everything on our hands, we look at it and say, okay, everything is good. So it's a totally separate field of testing data preparation. There are two types of testing data preparation. It's either manual scanning, when the tester takes plant and moving it over the jaw, mandible, gets the results. We can also use emulation for the testing, playing back some of the emulation data, the data received from the font. During manual scanning, we use tipatons. These are models of jaws which are actively used in medicine and dentistry, but sometimes we are lacking tipatont power because to test the algorithm which removes so-called soft tissues from teeth like cheeks and tongue. Tipatons don't have this, so for that you need to do intraoral scanning on a live human being, and the tester must scan himself or herself or his colleagues and friends. Yet another particularity, we're not prepared for such kind of sacrifice each year, of course, but if we look at the level of simulation here, like data recording and stuff, here we have another popping up problem, and we have sometimes collect big data and it's hard to manage them. We have about half a terabyte of recorded data that we are actively using. Forget about some archive data, we have too much of it. Naturally, when testing some kind of case, it's better to test it through emulation instead of live scanning, but sometimes it's hard to find a good replayable set. We haven't found a solution yet here, but one of the solutions that we see is to use some kind of system with a possibility of searching and finding it based by tags. For that, you need to tag all our recordings, and by simple requests, you can retrieve them. One example would be the tester's screen, tipatons, fans. That's how we work. A few words about the automation. In fact, scanner is a medical device, and it puts some additional responsibility on us because we undergo audits from the control agencies appointed by the state. So it's hard for us to remove the regression scope, and for small fix we have to do a lot of regressions to release it, otherwise it won't be approved. That's why automation is highly requested to make our releases quicker and less expensive. We use some elements, unit tests, APIs, which are mostly used for algorithms, and unit tests like user scenarios. I will tell you about API layer now. The most interesting layer of all, I guess. The thing is that the scanner itself is a monolith, if you will, which has a graphic user interface. Of course, we don't have a native API. We have decided to add to the special testing sets a program interface which could be actively used in the tests. We don't have it because it's physically impossible to connect it through API. As we have seen in testing the algorithm, the validation method we use mostly is visual method. So in order to upgrade it to the program level, we have added some methods to get the current status of the model like this. For instance, for the algorithm, which detects the roughness or imperfections locally, you use special matrix to validate it. Herefrom, we have yet another interesting thing which shows that algorithms do not always show similar 100% results. Maybe visually it is not detectable, but in numbers or digits, the difference can be some increments of percents. So that's why we have removed from strict asserts. Instead, we have some deviation possibilities. And a couple of words about ACI. Same thing like everywhere else for API tests. We launch Comet links, and if SV tests drop, the only problem we had with polarization on the scanner, although we interact through the program interface, software interface, still it is launched in a graphic mode. We don't have headers, and single test can be worked on a single machine only. So for that, we needed an orchestrator, which would have run our farm. Anyway, interesting story. It's still a work in progress. Generally speaking, that's all I had to tell you. Just a few more words to summarize what I've said. To compare my experience with experience in web services, I can say that scanners are an interesting piece of technology. I'm not complaining about my job. I had a lot of challenges in the past when our wealth of experience did not help even. Anyway, I think I have upgraded a lot of my skills and knowledge because of this. Thank you very much. Yes, Pavel, thank you. Now we have time for only one question, but we have more hands than one. Oh, my name is Anatoly. Tell us, please, you have quite a complicated domain. What is your testing team made up of? Did you try to hire as testers the actual stakeholders like orthodontists or dentists themselves, which would have improved the quality of testing? Yes, thank you for your question. Of course, my team is just a first frontier. We also have the so-called VNV teams, validation verification teams. They, of course, all of them have medical education. They do acceptance tests. Additionally, we have doctors we have close relations with, like beta testers. They get a better apps and they provide us with feedback. People had other questions. So after the presentation, if you move over to a different room where you can sit together, drink some coffee, and communicate. Thank you, Pavel. And this section is done on